So today we will be solving one more question from the heat transfer, which was asked in the GATE 2020 session 1. Right. So this question is basically based on the lumped parameter analysis, which is one of the topics in the heat transfer. So before solving on this question, let us have a quick brush up on the concept behind it. Right. So this is from the topic lumped parameter analysis. And what does it says? It says that internal or the conductive resistance is very less as compared to surface convective resistance, right? In such a case, the temperature distribution would be given by initial temperature minus ambient temperature divided by the temperature, right? The temperature. So this is the formula. There is derivation behind it. This is the ratio, right? Rho to V into specific heat into the right. So if I write it in the general form, H divided by rho into V Cp to the temperature natural log. If you remove this E, we can write it as change in temperature, right? Where Ti is the initial temperature, right? T be the temperature at time, T second, right? T infinity be the ambient temperature or the temperature of the surroundings, right? Rho, you know the density, right? And H with the heat transfer coefficient, A be the area, V with the volume, Cp be the specific heat, right? So if you calculate the area upon volume, right? So here we have this the area, surface area of the body to the volume of the body. So as per the question, we can just calculate it for a simplification, like the kind of the structure which will be given in the question. Like in this question, we'll read it out first. A small metal bit which is having a radius 0.5 mm, and okay, its R is given, and initially at a temperature of 100 degrees Celsius, where it is Ti, when placed in a stream of fluid at 20 degrees Celsius, attains a temperature of 20 degrees second in 35 seconds, which is T, which is 28, T infinity with the 20. The density and specific heat are given 8500 kg per meter cube, and Cp is 400 joule per kg Kelvin. Now if the bead is considered as a lumped system, right, as we have studied, the convective heat transfer coefficient that we have to find in between the metal bead and the fluid stream, right? So this is what we have to find. Now we know that for the bead would be in the spherical shape, right? So for the spherical shape, if we simply solve it out as per the radius, 4 by 3 pi r cube divided by area of sphere, right? So we will be having r by 3, right? Now further, from the given parameters, if we try to solve it out as per the formula, it would be ln of 100 minus 20 divided by 28 minus 20 degree, right, which would be equal to h into 3 into 1000, right, divided by 0.5 into 8500 into 400 multiply by 4.35. So it would become, if we remove this natural log, 2.302 into 0.5 multiply by 8500 multiply by 400 divided by 3000 into 4.35. So on solving it out, we get the value 299.87 watt per meter square Kelvin, which is our heat transfer coefficient. So this is how we solve equations if there is a temperature difference in between the conductive and the convective surface, right? So in this question it has asked for the calculating the convective heat transfer coefficient between the metal bead and the fluid stream. So the right answer according to the options would be B option, right?